Hi guys, welcome to today's video. This is going to be a quick just introduction to solubility. Now the best thing that you can remember about solubility is like dissolves like. So what do I mean by that? Well, what I mean is that there's two main types of molecules you can have, or substances. You can either have ones that are polar, or you can have ones that are non-polar. Okay? Now, if you don't know what the polarity of the molecule or substance that you're looking at is, you might need to look at the structure. All right? Now, things that are polar have generally what we call polar functional groups. Now, there is a video I've done on functional groups. You might want to have a look at that. But generally, those polar functional groups that we're talking about are things like hydroxyl groups, OHs, or you might have COOH groups, so the carboxylic acid group. You might have NH2 amine groups, okay? These are if you've got big molecules. If you've got small molecules, you can just simply draw the structure and work out if it's a polar molecule or not. Non-polar molecules are ones that have no net direction of charge, okay? So, the general rule of like dissolves like, what that means is that if the molecule or substance you're trying to dissolve is polar, it will dissolve in polar solvents. And if it's a non-polar substance, it will dissolve in non-polar solvents. So, what I'll do is I'll just give you a couple of examples of that. Okay, so I'm going to start off with things that are polar, because that's a little bit simpler. So the most common solvent that we use, okay, the one that is used not just in chemistry but around the world in a lot of different applications, is obviously water. Okay, so water molecule like this. Like I said, if you've got a small molecule, you can actually draw the structure. So a water molecule like this has a net direction of charge due to the unequal sharing of electrons between the oxygens and hydrogens there. So we have a net direction of charge. That's a polar molecule. Okay, so if your molecule is polar, okay, it will dissolve in other polar substances. Some of the most common polar solvents that we use are things like methanol, CH3COOH. We've got ethanol, which is C2H5OH. All right. Another one which works really well for both situations is acetone. Acetone is this one. Now, acetone has this group in the middle, this ketone group, C-double-bond-O. That's quite a polar group because you've got quite a large difference in electronegativity between the oxygen and the carbon. That gives a delta minus here and a delta positive on the carbon. That's quite a polar group, so that will allow it to dissolve polar substances. It does have non-polar ends here of the CH3, but they're quite small, which allows it to therefore dissolve polar substances quite readily. So if you've got a polar molecule, you can do a solubility or dissolve it in a polar solvent. Likewise, if you've got a non-polar substance, you can dissolve in a non-polar solvent. And some of the non-polar solvents that we use that are quite common, well again, you could still use acetone. I'm going to leave that up there. Because you've got the CH3 groups at the end, which are non-polar, they could dissolve non-polar substances, okay? But some of the other more common ones that we use, probably the most common one in a chemistry laboratory is something called dichloromethane. So dichloromethane, as the name suggests, has two chlorine atoms on a methane molecule. Okay, these chlorines are negative, okay, the hydrogens are positive, okay, and then the carbon in the middle kind of moves between the positive and the negative depending upon which bond you're looking at. But that's a non-polar molecule and that will dissolve other non-polar substances, okay. So that's one example, that's another one. Another one that we quite often use, okay, is cyclohexane, which is this, okay, it's just carbon atoms. Each of these little points is a carbon atom, okay, it's a non-polar molecule, dissolves things really, really well. So just for a brief explanation of solubility, that's all I'm going to go into. The main thing you need to understand is that like dissolves like. So you look at the polarity of the molecule, okay, if it's polar or non-polar, and then work out if it's going to dissolve in a polar or a non-polar solvent. The last thing I am going to talk about though, which is important to understand, is the impact that the size of the molecule has on the solubility. Because it's not just necessarily always easy to say, okay, well it's a polar molecule or it's a non-polar molecule. You need to have an understanding of what impact the size of the molecule also has. Okay? And to do that really quickly, I'm just going to compare two different molecules which have polar groups but have different solubility. Okay, so I'm going to compare methanol, CH3OH, and I'm going to compare that versus something like octanol. All right, so octanol is C8H17OH. All right, so we're comparing the two of them. They've both got this polar group in there. So I'm going to grab a slightly different color to show this. I'm going to grab the blue. So this OH here, this hydroxyl group and this hydroxyl group, they are what we call polar groups. Okay. So as I said, there is a separate video on polar functional groups, so you might want to have a look at those. But both of those are polar. Now the difference is that methanol over here, CH3OH, has a very small non-polar section, this CH3. So this is water soluble. All right, so that will dissolve in polar solvents. Whereas C8H17, which has a much higher molecular weight, right, due to this very, very big C8H17 group, which is non-polar, that is only non-polar soluble. Okay, so that will only dissolve in generally what we call organic solvents. So the molecular weight or the size of the molecule is important if you have polar groups like this, but again, you might want to have a look at that video on polar functional groups and compare that to this one as well. The key thing to take out, remember, is like dissolves like. So if it's a polar molecule or if it's got lots of sites for polar bonding, such as hydrogen bonding, okay, then it will dissolve. If it's a non-polar molecule, then it will only dissolve in non-polar solvents. All right, hope this has been helpful. Thanks, guys.
This is real love. This is real